First, so a little bit of background about grammars. A lot of the tools we've seen today, especially like Tableau, but also tools like ggplot, D3, Vega Lite, are based on this formalism of visualization called the grammar of graphics. It's this really incredible system and also big visualization textbook from 1999. And the basic idea, and we've seen this in some of the talks just now, is to break visualizations into marks like bars and dots and lines, channels like size, position, shape, and also coordinate transforms. And this is used not only to create visualizations, but it's also kind of the way that we teach visualization in a lot of classrooms. And the idea behind developing grammars or languages is to have this very structured, systematic space that we can use to sort of like, I guess, like build a web that kind of between different kinds of visualizations to understand how they're related to each other. And like at the time, the grammar of graphics was a huge advance over the attempts at systematizing graphics that came before. But it's sort of been like 25 years, and we can kind of ask like, how systematic are these relationships between different points in the visualization design space? So we could take something like a scatter plot. We're using a point mark. We have X and Y channels for position, and we have color for the weather. And a really natural thing to do in the grammar of graphics is to swap this point mark to a line mark, right? Okay, now we have lines. We're still using X and Y for position. But one thing you might notice is that in the scatter plot, we have one shape or one mark for every individual data point. But in the line chart, we have one shape for every color, right? So like there's this kind of interesting trade-off between things that we want to be like easy to move between and then really, differences in the structure of the visualization that we're changing between. So here's another example. We can change the mark type from line to bar. And one thing that, at least when I was first learning the GOG, was really confusing to me is that in the first two, we're using Y to represent the positions of marks, but actually in the third one, we're using Y to talk about the height of the bars. And you'll also notice that the positions of these bars isn't being expressed the way it is in the first two, but actually there's this like implicit vertical stacking going on. And that, further becomes a problem because maybe we don't want to vertically stack, we want to horizontally stack. We saw that there are a lot of differences in the kinds of inferences you make between these different representations in Cindy's talk. So in Vega Lite, at least, this is done with like another encoding channel called X offset. So it's weird. So like, why are we using X offset here, but there's no Y offset for the vertical stack? Like, why are we kind of doubling up this weather encoding? And, for such basic charts as like stacked and group charts, it's kind of strange that we have all these weird inconsistencies. And so what hope do we have for all of these other like more complicated charts? Like, how are we going to make this armadillo? Like I don't know. So that's the motivation for this project, which is a grammar of more graphics. And our key insight is to say there's all this rich visual structure. Not only is it like important for specifying and thinking about graphics, but also for the kinds of takeaways we have. And so our sort of idea was like, well, there's all this perceptual cognitive science literature on the structure of, how we perceive graphic structures, and like, could we put this into the grammar of graphics? So now I'll kind of walk you through some of the visual structures we've done so far. Like these primitives are all sort of in flux, but I want to show you some of the things that come up a lot. So some basic spatial arrangements that you see in like a stacked bar chart are this sort of like stacking thing, even spacing between elements, or like scattering where you have these like data-driven positions. Then there's this other collection of Gestalt grouping principles that are about things that sort of draw marks to connote relationships. So we have some kind of connection, which you can use to draw line charts and area charts, and also enclose, which is kind of like drawing boundaries around regions. So let me switch to a live demo of the alpha version of of GoFish. Yeah, so here I've just basically drawn a rectangle mark on the screen. It has some position, some width and height, some fill color, and then also we're specifying kind of the size of the container it's running into. And we have a basic data set, which is this sort of seafood data set that we made. So it's basically like an array of, imagine we've collected a bunch of fish in like 6 different lakes. The fish have some different species, and we're like, okay, there's like 23 bass in Lake A, let's say. So maybe the first thing I want to do is just see like how many fish did I catch in each lake. So what I'll do is I'll attach this seafood data set here, and then I'll use this spread operator to basically to say, okay, I want a bar for every lake. And now instead of using this Y encoding, I'll just use the height of each rectangle and say, okay, the height of that rectangle is going to be the count in each lake. So notice, like, I'm not using Y for position. I'm using I'm using height for the height of the bars. Now let's say, okay, maybe I want to see within each lake a distinction by species, like what's the count per species. So I can create this vertical stack within this species here, and now I can change the color independently to change the color of each bar by the species. And because I've made these visual structures, the Gestalt principles, distinct from each other, I can turn this stacked bar chart into a group chart by just changing the stack Y to a stack X, and then get like, this nice horizontal thing. Some other moves like sort of present themselves really nicely this way. So instead of grouping by species and then kind of lake on the outside, I can swap those. So I can do lake on the inside and then species on the outside. And then I get another one of the charts we saw in Cindy's example. Another one that is very natural from this point is, maybe what I want to do is I want to compare like how are, the relative, like what's the most common fish in every lake, right? So maybe what I'll do is I'll add this transform to basically sort within each category, like, okay, which species is most common? So now I can see, well, salmon are the most common in Lake D, but it's kind of, catfish here in lakes B and C, right? But we can imagine maybe the lakes are connected to each other by some river. So we want to really emphasize or point out this pattern that's going across all these different lakes. And so the way I can do that is I can use this connect operator. And I can say, well, connect species over each lake. And now let me play with some of the some of the settings here. So like we'll make the width of each of these smaller, and then I'll just change the spacing, maybe be a bit wider. And I can change the opacity here to make it like maybe a little bit more aesthetically pleasing. And now we can see this kind of like underlying stacked bar chart structure, but we get this ribbon with like one command, right? So like in this model where we only have marks and channels, it's hard to say what is the mark of a ribbon chart, right? It's like something in between an area chart and a bar chart, right? So like if I turn the opacity all the way to 0, I have a stacked bar chart. If I take the width of each rectangle to 0, I have some sort of like stacked area thing, right? And so the power of this kind of splitting out these structural pieces explicitly is now that, this kind of intuitive thing that these charts are related is expressed in a really explicit way formally in the system. Some other things that are kind of fun to do here, so I can change the alignment to be like middle aligned, and maybe I'll take out this transform, and now you'll see that actually I'm making a stream graph, basically like immediately. So like there's all these cool things. We're like, oh yeah, a stream graph is like a middle aligned stacked bar chart, area chart thing. Like it gives us a way of talking about the relationships between all of these charts in a way that's like we think is easier than in the original GOG. So that's the system. We have lots of other fun examples that we're still like working on. So I guess like some questions that I'm maybe interested in or maybe would like to seed for people is like, I think there's been some interesting research on the sort of visualization effectiveness side about what makes it one chart better than another. That's really rooted in the kind of like marks and channels model. And then there's been a lot of questioning over like, well, if we take that model literally, then everything should be a scatter plot, right? And I think, I don't think this is like the full way of addressing that question, but I do wonder like, are there ways that we can add this notion of Gestalt principles in a slightly more formal way to start asking these effectiveness questions in a slightly different way. I'm also curious about like other kinds of structural principles that jump out to people as being interesting. I'll also say I'm also on the job market. I don't know what I'm I don't know whether I'm going to go the faculty route or the industry route, but I'm really excited to chat more about what kinds of collaborations we might be able to have. So thanks, I'll leave it for questions.
Great, we have time for a few quick questions.
So there's super cool stuff. So I'm really familiar with ggplot, and it has this idea of like the pluses, like you're building up a plot by adding error bars and adding scatter plot. And so I'm just wondering how you think in terms of metaphors of your kind of more pipeline or methods that work on methods versus this sort of building up.
Yeah, that's a great question. I think we've kind of been playing around with two sorts of syntaxes. It's kind of like really fast high-level syntax for charts that are very linear like this, and a more expressive lower-level syntax that lets you do layering in a more explicit way. And I think we're still trying to explore like how do we get all of those things. So the layering metaphor is really cool, and in some sense you could think of it as a Z stack. So like maybe you just do like stack Z, There are ways you can think of sort of punning the metaphors. Yeah.
Okay, time for one quick question. Can you unplug? We'll get
Yes.
Arvin set up and have one more question for you.
Hey, thank you for the great talk. I'm curious to hear your thoughts on whether you think visual and textual annotations, which is a big part of like telling a story with data, could be or should be incorporated as part of the grammar of graphics for visualizations.
Yeah, that's a great question. I think absolutely they should be, and also that like the structural operator approach gives a much more natural place to get there, because you can say, I want this text to be close to this item. I want to draw a line between these two things. In a way that we've explored in our previous system, Bluefish, which is more like lower level diagramming stuff, which is there again, like annotations become a huge part of it. So I think like it's definitely something that we want to support, and I think is afforded by having like explicit visual structure. Yeah.
Wonderful. Thank you so much.